We are given a Poisson measure model for students leaving a university over a 24-hour period. And this model is made in terms of an intensity measure. This intensity measure, labeled mu, has two distinct components. It has a summation component, which looks sort of like an unnormalized probability mass function. So we could think of that as a mass function. It's unnormalized because if you sum from 1, i.e. A is 0, up to 24, i.e. B is 24, it won't equal 1. That's fine for intensity measures. And the fact that this part will increase on the hour rather than in between hours means this is the intensity of students leaving on the hour, i.e. perhaps after classes end. The second component resembles a probability density function, and it also will not be normalized in the sense if you substitute A is 0 and B is 24, you would not get 1 or a half. And this would represent the intensities of students leaving in between the hours. And so these two components have very different aspects. And we are asked, what is the probability that 150 students leave exactly at 12? So we suspect that this has more to do with the first part than the other part. But to solve this problem perfectly and to demonstrate that we know how to solve this problem, we should look at, well, how can we get mu of just the one number 12 from mu that's given over this half open, half closed interval? And the way that we do that is we set B equal to 12 and then we let A drift up to 12. And when we do that, we'll see that the lower part of the summation will remain always at 12. It will never go to 13, even when B is 12 and A is just before 12. So 11.99 plus 1 is 12.99, but then we take the integer part and we'd be summing from 12 to 12, so we just sub I is 12 into that formula and we get 12 times 12 is 144. The limit of the other part, though, if B is set to be 12 and A is taken as a limit up to 12 of this integral, we are converging to the integral over just one point, which has 0 area, in which case that part would be 0. So we would be left with, after taking the limit, 12 times 24 minus 12 plus 101.221, the integral from 12 to 12 of t e to the minus t over 10 dt. But that is just 0. So the intensity measure right at 12 for students leaving at that exact time is 144. Hence, the Poisson measure at this 1 point set 12 is 144 Poisson, and we can plug that into a normal Poisson probability mass function to compute the probability that is 150. And this would give us e to the minus 144, 144 to the power 150 over 150 factorial, which is, after using a calculator, 0.028779.